Welcome. In this video, we're going to talk about React hooks. So what are React hooks and how they help us build better components? In essence of it, hooks are functions that have to be called inside React functional components, and their purpose is to enhance these components with various features, such as defining local state, enhancing behavior in component lifecycles, and more. In previous versions of React, functional components were strictly what we call stateless components. Their purpose was to just render something based on props, and that's it. With the advent of hooks, that's no longer the case, and functional components can now be stateful as well.
For example, previously if you wanted a component with a state, you had to declare a class component that extended React component and initialize state in it. Like that. In this example, we added a component with local state that had value of counter equaling to 1. When you click on a button, it increments the value of the counter by 1. And that's the component. With the advent of hooks, this can be rewritten in a much shorter way. Like this. In this code, React useState is a React hook that allows defining local state. The logic of the component is pretty much the same, and clicking the button increments the counter by 1. But the code is much shorter, cleaner, and easier to read. Adding local state handling is just one way React hooks can enhance functional components. We'll mention other types of hooks later in the video, but first let's understand a few more reasons why you should use hooks.
So why use hooks? With hooks, you can write your application with just functional components. You can almost forget about those bulky class components and complicated higher order components. Next, writing components with hooks requires noticeably fewer lines of code. And third, as a result, it's easier to read the code and reason about the complex parts of your application. Fourth, hooks are highly reusable and provide an easy way to define a component's logic once and reuse it in many other places. And last one, you don't need to worry about the this keyword anymore. Let's go over these benefits one by one and provide you with an example for each.
You can now use functional components instead of classes. As I said, almost everything that previous versions of React required class components for can now be written using functional components. For example, useEffect hook can be used to replicate lifecycle behaviors, and useState can be used to store state in functional component like what we're going to show you next. So let's take this counter component as an example. It prints the current counter value and increments it every 2 seconds. That logic is defined in component didMount with the set interval. When you remove the component, the unmount lifecycle kicks in and removes the counter. This logic is defined in component will unmount and in the parent app component. When you click on button, it removes the counter. Now, we can rewrite it using a functional component and React hooks. First, to define a state in a functional component, we need to use React useState. So let's replace this bulky class component with a functional component that uses React useState. As you can see, the counter is being shown in the output as expected. Next, we will want to add a set interval that updates the counter every 2 seconds. For that, instead of using the default React useState, we'll use a convenient custom hook that you can download from npm called React-useStateRef that gives us an ability to add a stateful hook and retrieve current values in callbacks. But because I'm using CodePen, I decided to just copy paste the source code into my CodePen and call it the function React-useStateRef. Let's finally add the logic that updates the counter in an interval. The component will need to be enhanced with React useEffect with an empty array in the second argument. But first, let's add the new useState here. Now let's add React useEffect. We also use React useRef to store setInterval in reference so that we can clear it later. When you run the component, you will see that the counter is updated every 2 seconds. Alright, now let's do the last thing. Let's remove the interval when the component is removed from the tree. For that, we will use React useEffect to return a function where the cleanup of the interval can be done. This is similar to the lifecycle method component we'll unmount. Now, let's play the back. So the counter is updated every 2 seconds, and when you call remove counter, it clears the interval. Next benefit, hooks result in fewer lines of code. So while we're at it, this is also a very good opportunity to show you that in general, React hooks will result in fewer lines of code. Here's the class component, if you don't remember. This is approximately 26 lines of code. And here's the equivalent functional component. This is about 19 lines of code. So 26 versus 19 lines of code. When you that's 18 lines of code less, or 20. Considering all other options equal, hooks definitely seem to have the advantage here in terms of brevity of code.
As a result, it's easier to read the code and reason about the complex parts of your application. This goes without saying almost. The less code there is to read, the less there is to understand. This is not to say that you're 100% protected from spaghetti code when writing your hooks. However, if you follow solid software engineering principles, and if you don't know them, look them up, you should generally be fine. Out of hundreds of developers I've interacted with, pretty much all of them seem to prefer the declarative syntax of hooks. This goes to show just how much more elegant the hooks API is compared to classes.
Hooks is it makes it much easier to reuse your code across different components. Let's take our original class component as an example. What if I had a component A and a component B that both wanted to reuse the same logic that increments their counters every 2 seconds? Something like this. Of course, you could have duplicated the code in both of these components, but duplicating code is almost never a good sign. In order to reuse the same counter interval logic between those two components, you could turn this class component into a higher order function. So let's define this function. Now, we'll make it take a generic component and return a class that extends React component. And then we can implement the interval inside this final class. The code that we just entered will look very familiar to you. We took it from the original class component. So now we have a function that takes another component and creates a class with a shared logic, just like how we wanted it. Now let's create the higher order components. by wrapping the DOM components into the function we just created. And let's render them in the main app. Now we can observe that the output are two components whose counters increment every 2 seconds. Let's go back to our original implementation of a component that uses a hook. We'll change it into a reusable custom hook this way. Now let's use this function, which is a custom hook, inside our new functional components. Like this. And let's render them. That looks much easier, right? It definitely is. And the last reason why you want to use hooks is you don't have to worry about the this keyword anymore. If you work in JavaScript for any extended period of time, you know that this keyword can be quite tricky to use, which is why most people use arrow functions these days. Well, if you use React hooks, you don't need to worry about this keyword anymore because there's no need to use it.
Now that you know what some of these React hooks are capable of, it would be a good idea to give you a list of some standard hooks that you want to know about. They are use state, use ref, use effect or use layout effect, use memo or use callback, and use context.
The useState hook allows React developers to read and manipulate states inside functional components. Our previous example made use of useState to display counter value inside the functional component. So the hook useState returns an array of two values. The first value is the current value of the state variable. In this example, it's equal to 1 because 1 was passed to the useState hook, and that makes it the default initial value. The second one is the function you can use to change the value of the state variable counter. Let's modify the example to make use of the second argument. And let's call the second argument setCounter. We'll also add a button that will call a function called addCounter, which subsequently calls setCounter and increments counter by 1. So clicking this button will change the counter, the first argument, by 1 because that's how we defined the handler. The next hook we'll talk about is useRef. UseRef is used to hold a value that persists for the lifetime of the component. It can be used to hold any arbitrary value. You remember how we use useRef to hold the current value of setInterval. A more popular usage of useRef, however, is to set it to some HTML element. In this example, diffref gets populated with the reference to the diff. And the code changes the background color to yellow 2 seconds after the component is mounted. So let's click the button so that this component is mounted. As you can see, 2 seconds later, the background changed to yellow. And we used pretty much the vanilla JavaScript API. All HTML elements contain a prop ref, which will populate the ref current with the reference to the actual vanilla HTML element. Let's talk about useEffect and useLayoutEffect. UseEffect is the main way to trigger something in response to something else inside your component. It's also often used as a way to create a component didMount effect, just like how we did it in our previous examples. This example will show a different way useEffect is used, when you pass something that is not an empty array to the second argument. Basically, what happens is some component will react to every time props counter changes, and this props counter comes from the parent app component here. And every time props counter changes, it sets the local counter to be 10x of that. So let's click the button and observe that the props counter is incremented by 1 and local counter is multiplying props counter by 10. One important note is useEffect runs after React renders our component and ensures that an effect callback does not block browser painting.
Now, what about useLayoutEffect? The signature is identical to useEffect, but when it's called, it's different. It basically runs synchronously immediately after React has performed all DOM mutations. Use this to read layout from DOM and synchronously re-render. Updates scheduled inside useLayoutEffect will be flushed synchronously before the browser has a chance to paint, unlike useEffect. UseMemo. It returns a memoized value. When you pass a function and an array of dependencies, UseMemo will only recompute the memoized value when one of the dependencies change. Otherwise, it will use the previously computed value. This optimization helps to avoid expensive calculations on every render. UseCallback is similar to UseMemo, except it returns a memoized callback. The distinction is very subtle, but basically, you can rewrite UseCallback using UseMemo using the following rule.
Let's talk about useContext. UseContext is a convenient way to access a React context using hooks. React contexts are primarily used when you want to access data at deep, nested levels without having to explicitly prop drill the values from top to bottom. First, let's show you how you would use a React context before hooks. First, let's define the context. We'll create something that's called a theme context, and its purpose is to pass some styling values. Then you wrap the subtree of your app in the context provider. Something like this. Then we will create a component that does not pass any props from the parent to the child in order to show you how context can achieve that instead. And finally, let's create the final component which will take the value from the context. Now, when we refresh the app, you'll see that the background color, yellow, is passed all the way from the app, and we didn't need to prop drill this through each levels of the chain. Notice how this render prop pattern is required if you use context in the old way. Not many people like using render props because the pattern just looks awkward. With hooks, you don't have to use render props. Instead, you can use theme context in our example in the following way. The result, as you can see, is the same, but the syntax is much less convoluted, which is a great thing.
Thanks for watching.
If you like the content we're providing,
Please like and subscribe to help us grow the channel. Thank you.